project or software engineering project, one of the key things that you must do is specify the requirements of that project. So what I thought I'd do with the project PhysLean is specify what the requirements of this project are. The first requirement is that the project should contain formalized results from physics organized by physics. And what that means is that we're going to take results from the physics lecture, we're going to write it into the interactive theory and proof at Lean 4 and include it within the project. The second requirement is that the project shall contain lean tactics, notation, and syntax for the physicist. These tactics, notation, and syntax will enable the physicist to write down stuff in the language that they expect or that they would if it was on pen and paper. It will allow them to prove things similarly to how they would prove things on pen and paper as well. The third requirement is that the project should not be tied to any axiomatization, but be flexible enough to accommodate different approaches to physics. What I mean by this is that, for example, in special relativity, we're not going, you have to have an axiomatization of special relativity and build up from that. You can pick a well-defined starting point and work your project from that point. This is exactly the same thing that physicists do when they write papers. Not every physics paper starts with an axiomatization. In fact, very few do. The fourth requirement is that the project should be completely open source, community run, and independent from any company or organization. It's there for the community. It should be guided by the concepts or the wants of the community and guided by input from the community, not an individual company or organization. The project shall be carefully reviewed or curated to ensure reusability and readability. In other words, it's not just like every physics result formalized into physics formalized into Lean goes into the project. Is carefully curated and managed to ensure that it is usable and reusable and readable to the users and making a project that people can use with ease. The project should not be tied to any specific AI model. We're going to use this is going to be the output of this AI model, and that's what we're going to restrict to. It's very general, it's open to everyone to contribute to, independent of if they're writing the code themselves or using an AI model. The project should be of use to the academic community. That means it should be of use to people doing like string theory, quantum gravity, quantum field theory, quantum mechanics, condensed matter physics, etc. And lastly, the project shall only be for mainstream physics. Lean doesn't stop you doing things which are stupid. It doesn't stop you doing non-mainstream physics as long as that non-mainstream physics is mathematically correct. PhysLean isn't about that. It's not about that. PhysLean is about mainstream physics only.